In section 4.4, we're going to talk about applications of compound interest. So we're going to be using this compound interest formula. A equals P times 1 plus R over N raised to the NT. You don't have to memorize this. I'll give it to you, but you are going to have to be able to use it in lots of different ways. So you really have to know what everything stands for and how to use it. So the A is going to be the amount that we have after time t. Lots of times this we'll be talking about money and investments, but not 100% of the time. So sometimes we may refer to something not necessarily money and investments, but we'll describe it that way here. The P stands for the principal if we're talking about money, or it's the starting amount if it's something other than money. The R is an annual interest or the percent growth if we're talking again about something other than money. So if it's a 6%, that R we're going to have to change to a decimal and make it 0.06. So you have to convert it from a percent to a decimal before we can use it in the formula. N is going to represent the number of times per year interest is compounded. So if it's compounded annually, the N will be 1. If it's compounded quarterly, the N will be 4. If it's compounded monthly, the N would be 12. And if it's compounded daily, the N would be 365. So those are the most common ones. T is going to represent time. Usually it's going to be represented in years. So looking at the green here, we're going to compare 12% interest compounded annually versus 12% interest compounded monthly. And for this comparison, we're just going to invest $1,000 and for 1 year only. So when we do that, what we'll get for the interest compounded annually is the amount that we will have will be our principal, which is the starting amount. That's going to be for us 1,000. We'll get 1 plus our R is 12%, which we're going to make into 0.12. So we'll change that percent to a decimal. The N, if we're compounding it annually, means we're going to compound that once per year. And so our N in the exponent is that same N, 1. And our number of years is also going to be 1. And so we will get then 1,000 times 1.12, and when we do that, we'll get 11,000, we'll get $1,120. So that's what we would have at the end of that 1 year if we got 12% interest compounded annually. Now, if we're going to do it for more years, then that interest that we earn, that $120, would continue to earn interest in the next year. So interest earns interest when we're talking about compounding. Now, if we're talking about monthly, then what we're going to get is A equals, we're still starting with 1,000, so that's still our principal. We still have 1 plus, still going to be 0.12, but now because we are compounding monthly, that's going to be a 12, and our N is going to be 12 times the 1 for the number of years. So that is going to look like the 1,000 times 1.01 raised to the 12th power. So that, when you enter it into your calculator, you should get $1,126.83. So you can see through the compounding process that we have earned an extra $6.83 in that first year because of the power of the compounding. Now, we're going to talk about some vocabulary here. So we see in the blue here that the nominal annual rate, or the nominal rate, you'll hear it said both ways, is 12%. So in both examples, when we have the annual interest rate, but also when we're doing it compounded monthly, we would say the nominal rate is 12%. That's our annual interest rate. And nominal means in name only. And we can see that we got very different things from our same nominal rate depending on how many times we compounded it. So the effective annual rate or effective rate in the United States, that's referred to as the APR, the annual percentage rate. That is going to be what we actually got due to the compounding. So we can see that we had that $1,126.83 at the end of the year. If we divide that by the 1,000 we had to start the year, we can see that'll move the decimal over 3 places. So that's going to be 1.12683. And that is, as we have seen before, the 1 plus r. If we subtract off that 1, our r is 0.12683. And if we change that r from a decimal to a percent, we can see that our effective rate is 12.683%. So when you're being asked to find a rate, that's an interest rate, and so it should be given as a percent. So you can see the nominal rate was 12% in both cases, in both examples, with the interest compounded annually versus the interest compounded monthly. But the effective annual rate in the case of the investment being compounded monthly was 12.683%. Okay, these are important words to be able to know here. We're going to go to the screen and work some examples. So what is the effective annual rate of investment that pays 6% per year compounded daily? So again, to find out the effective annual yield, we want to let the P be 1, makes our life easier. You don't have to do it that way, or you can just leave it as P either way. And we can choose the time. We need that to be 1 year. And so we're going to get A is equal to, I'm going to leave the P just as P so you can see it in a more general form. So it's going to be P times, we'll have 1 plus, the 6% is going to become 0.06 when we convert it to decimal from a percent. And daily means our N is 365, and that will be raised to the 365 times 1 is 365 power. So this goes into your calculator, and so we're going to get that P will be multiplied by, let's see, I think it's going to be 1.06183. And so that is our 1 plus r. So if we subtract off the 1, and the P is just our initial amount, whatever that was, what we see here is our growth factor, what that's growing by. And so we will get the 0.06183, and that will convert to 6.183%. So our effective yield, that nominal rate we say of 6%, is going to give us an effective rate or effective yield, sometimes it's also called, of 6.183%. So the compounding it daily increases the return, how much you're actually getting each year. So the next one says, if you invest P dollars at 4% per year, compounded quarterly, by what factor does P grow in 5 years? That's the first question. Now, a factor, remember, is something that multiplies something else. So the factors of 15, you can say, are 3 and 5, because 3 and 5 multiply to be 15. And then after we answer that, we're going to try to find what percent does P increase. So let's see what we've got. We've got A is equal to, we have P dollars that we're investing. It's going to be 4%, so we're going to go 1 plus 0.04, and that's quarterly, so that means we're going to get 4 for the N. We're going to do this for 5 years, so we're going to get 4 times 5 in the exponent. So that means we're going to get P times, and because this divide so easily, I'm going to call that 0.04 divided by 4 is 0.01, and added to the 1 will be 1.01, and we're going to raise that to the 20 power. Now what we want to do here is, if we enter this into our calculator, so that 1.01 to the 20th, we're going to see what factor is multiplying that p. And so when you do that, you should get I think it's 22019. 22019. So our factor, by what factor does p grow, that's our answer to that. So our first question, the factor that this grows by is 1.22019. And then the next question, by what percent does it increase? To answer that question, we are going to see this as being 1 plus r. So if we subtract off the 1, it'll be a 0.22019. That's r as a decimal, which means that the percent that it increased by over that 5-year period is going to be 22.019%. So that may be surprising if you haven't had much experience with compounding, but you might have thought initially, if you weren't familiar with the compounding, that if it increases by 4% per year for 5 years, that it should increase by 4 times 5 is 20%. But in fact, it's more than that, and that's because of that compounding. That is, along the way here, interest was paid in, and then that interest in turn earned interest. That's what happens with the compounding. Okay, so let's look at the next one. Now here we have an investment decreases by 75% over a 10-year period. By what effective annual percent does it decrease? So again, we're starting with our formula that we are in most of these here, where we have our compound interest formula, and we want to know what effective annual percent does it decrease. That means what we're looking for here is what is the R. Now, that R is going to be a decrease, so that's going to be, we can think of that as like being a negative number here. So what we end up with inside here for our base of that exponent, because it's decreasing, is whatever this 1 plus r over n turns out to be is going to be less than 1. So let's see, if it decreases by 75% and we started with p, so 75% less than p means that what we have after those 10 years is going to be 25% of what we started with. Does that make sense? It decreased by 75%, so what we still have left is 25% of what we started with. And so then we're going to have the 1 plus the r we don't know. That's what we're looking for. Now this is effective annual yield, so in this case we're choosing then effective annual yield means that the n is going to be 1. So we're just compounding this once per year, and so our nt is going to be just t. So this is our equation that we have to understand what all these words mean and figure out how to put that into this equation. Then the next challenge is, how do we solve that equation? So the first thing we can do is divide out that p, so it doesn't really matter how much you started with. $1, $1,000, $1 million, it's all going to work out the same. So now, and we also have, I guess I should say, the t is going to be 10. So we have 0.25 is equal to 1 plus r raised to the 10th. So now to solve for r, ultimately, we have to first raise both sides to the 1/10th power, or take the 10th root of both sides, either way. So I'm going to write it as 0.25 to the 1/10th power, because that's how I'm going to enter it into my calculator. And on the other side, we're going to get rid of those and just get our 1 plus r. Now remember, This is decreasing, so we're expecting this r to end up being a negative number. Now, when you plug in 0.25 to the 1/10th power, I believe you're going to get 0.871. So that is our 1 plus r. If we subtract that 1 from the 0.871, we're going to get a negative 0.129 is our r. So remember, we're looking for the effective annual percent that it decreases by. That's what we're getting right here. So the negative is telling us that it's a decrease. So we're going to say that the r, now giving our answer as a percent, is going to be 12.9%. Remember, we're saying it's decreasing by this percent. You don't want to really say it's decreasing by a negative percent, because decreasing by a negative would actually be saying it's increasing. Okay, let's go to the next panel. Okay, so here we see if you need $100,000 in 10 years, what is the minimum amount you should invest at 4% annual interest compounded monthly? So remember, our formula here is A equals P times 1 plus R over N raised to the NT. So we want $100,000 in 10 years. That's telling us that the A is 100,000. We're trying to find out how much should we invest. So that's the P. We're trying to find out here what is the P. How much should we invest right now? So we're going to get 1 plus, and I guess we're going to get 4% annual interest compounded monthly. The 4% makes the R 0.04. Compounded monthly makes that N equal to 12. And since our exponent is N times T, and we want this in 10 years, we're going to get 12 times 10 makes that exponent 120. So there's how we decide what to put in which position. Now we're trying to solve that for P. So if we can recognize that all of this messiness here is really just multiplying the P, then we can solve for P by just dividing all of that messiness over to the other side. And now you can actually enter all of this into your calculator with one entry if you're just careful how you do it. So I believe if you do that, what I got anyway, if you want to compare here, is I think 30, let me pause it here and check. So what I'm getting on my calculator is $67,076.61 when we round that to the nearest penny. Okay, so let's try the next one. And in this one, we're going to have $10,000 we want to invest, and we're going to try to get $50,000 in 25 years. And what should our effective annual yield be? So the effective annual yield then means we're going to assume here that we're just compounding it once per year. So we want to end up with 50,000, so that's going to be our value for A. We're starting with 10,000, so that's going to be our P. We'll have 1 plus, and we don't know what that interest rate is. That's what we're trying to find, and our time is going to be 25 years. We're choosing N to be 1 here because we just want the effective annual yield. So to solve this, we're going to divide both sides by 10,000. So that's going to give us 5. And then we'll have 1 plus R to the 25th. So we will have to raise both sides to the 1/25th power, or take the 25th root. So this goes into your calculator. And when I do that, I'm getting 1.06649, and that's our 1 plus r. So if we subtract off the 1, we're getting 0.06649 is the r, and we want to give our answer as a percent, so moving that decimal over twice is going to give us 6.649%. So we need 6.649% effective annual yield, however we can manage that, in order to turn our $10,000 into $50,000 in 25 years. All right, very good.